Hi, my name is Bob Iannucci, and what I'd like to talk to you about today is a project that's actually relatively new. It's something we started last August at Carnegie Mellon University. We called the Survivable Social Network. This is something that a small team of students and I took on that sort of gained momentum. We've roped in some other faculty. I'll talk a little bit about their contributions as well. And this was all done under the sponsorship of the city of Palo Alto. That's gotten very interested in this idea of how do we help people in times of emergency at the community level provide communication services. So I'll do a setup for you. I'll give you sort of a perspective on what we consider to be an interesting problem. From that problem, we distilled some design principles for a potential solution. I'll talk about our approach, how we've evaluated it, and what this indicates as some future work. Again, this is relatively new stuff. It's not so well baked as some of the other things that you've seen today, and it's presented here for your comment and thought. So here's the problem. And you have to sort of think like a Californian to get this, right? So you have to rewind to the World Series in 1989. The Loma Prieta earthquake hit. At the time that happened, let's readjust our thinking to what time was like back then. So in 1989, we were a little more than 5 years post-divestiture. The telecommunication network the gold plating hadn't worn off yet. It was still robust and rock solid as it had been engineered back in those days. And yet when the Loma Prieta earthquake happened, the telecommunications infrastructure was shaken and stirred. 154 of the 160 central offices in Northern California lost primary power. Some of them lost secondary power too. But even our gold-plated, really robust, centrally engineered, slowly evolved telecommunications network was hit with a major communications disaster, and it had wide-scale impact. Now, what would happen if that same sort of thing happened today? Would we have the same scenario, or would it play out differently? Well, in fact, I think it would play out rather differently. 20 plus years later, our infrastructure is less robust. Rather than one company carefully engineering our future, it's a marketplace. We have internet service providers that go from Joe's ISP up to the largest ISPs in the world. We're largely dependent on wireless communication, and wireless has, as we've discussed, its inherent limitations and shortcomings. So the world is in fact different from a technology perspective, but it's also different from an end user expectation perspective. People are more reliant on communications than ever before. I'm a ham radio operator, and I like to read those stories of how in 1989 the ham radio guys rushed in with their handy talkies and provided voice services, much needed in the case of the telecommunication network being down. But nowadays, if that same disaster happened, me and my other ham radio buddies are going to rush in with our walkie-talkies and nobody's going to care. The reason that they're not going to care is because people's attention has largely shifted away from voice as a primary communication vehicle to data, as we've discussed. In addition to that, not only is it just data, access to health records, access to medical records, vesting useful information in the cloud, we've gotten very seduced to the modality of social networks as a way of exchanging information with friends and loved ones. So we trust the cloud. It's going to go away when networks are severed. We rely on social networks. The ham radio guys aren't going to be able to provide that. So these changes actually have increased our vulnerability relative to what happened back in 1989. So with that in mind, we took it upon ourselves to think about what would be a good replacement interim communication system, sort of in the spirit of amateur radio, that could be built grassroots up rather than infrastructure, big capex down. What would be the design principles for such a network? Taking a cue from those who train us in emergency preparedness. In a widespread disaster, the premise of the best resource to help you is the nearest one. We think in terms of creating something at the neighborhood level and building it back up, providing not necessarily replacement internet, but near neighbor communication within your neighborhood first, and then expanding in circles to encompass multiple neighborhoods in the city. Second, we have a hugely useful tool, if we could leverage, which is the predominance of HTML5-based smartphones. As a data providing device, these things are wonderful. They have communication capability in spades. They have data rendering and display capability. They run on batteries. They can be recharged by residual power in your car with a cigarette lighter in case of an emergency. If we could only create a system that just leveraged that capability, we wouldn't have to deploy walkie-talkies and special purpose devices if we could just figure out a way to relight up those cell phones that aren't working because we're presuming the local telecommunications infrastructure is down. And finally, we'd like to find a way to crowdsource the infrastructure that drives this, rather than relying on big capital investment. Can we do it with commercial off-the-shelf server technology and an easily deployed wireless network? So this is the idea of the survivable social network. It should be built, or we imagine it as being built, to serve 3 concentric circles. The inner circle, as I said, are near neighbors, people literally in your neighborhood, people who you are probably already friends with but may not realize that the person 4 doors down used to be a nurse and could provide emergency services in the case of a disaster, or even just having local information that would tell you where to get water, where to go to escalate a problem up to the city. Second level would be to expand that circle with something as prosaic and simple as commercial satellite internet service. Probably not widely useful in a disaster because it'll be overloaded, but the premise of being able to take a neighborhood and linking it to the broader internet, even through a thin pipe like a commercial satellite, would provide tremendous benefit if we could control access in a reasonable way so that we wouldn't have one person streaming cat videos and precluding everyone else from getting health and welfare messages through. And then the third would be to somehow integrate neighborhoods together so that we could get information escalated up to the city so that the city would have a back channel back to the community. And that's the basic idea of the survivable social network. It's made up of 4 component parts. The first, as I said, is to use the smartphones that people just have and know how to use. The second is to build a very simple, low-power server using Linux, Apache, and so on, running on 1 or 2 watt single-board computers or even on a laptop computer, connected to a Wi-Fi network that really could be just as simple as an access point connected to the rope of the flagpole at the nearby school that you sort of haul up to create a bubble of communication coverage. It won't be perfect. It won't reach every room and every house in the neighborhood, but it will provide broad hotspot connectivity within the neighborhood. Add to that the idea of software that mimics the functionality of traditional social networks. So on this little Linux single-board computer, imagine something that looks like Facebook or Twitter, meaning that it has the same sort of metaphors for posting messages and having timelines, being able to post pictures that people are already familiar with. And because it's delivered on smartphones via HTML5, it doesn't require installation, doesn't really require training. Add to that the possibility of using SIP or another alternative way to provide voice communication, and you've got the workings of a simple IP-based network that can grow grassroots up. So the idea of social networking on smartphones, no installation, very powerful idea. The idea of having your neighbors as friends and providing a means to sort of pre-enroll all the people in the neighborhood onto this little server would be a way of binding the neighborhood together. So our survivable social network software, the prototype that we've built, is a server that has a Facebook page. I ask my neighbors to sign up. They do that. The information from their Facebook accounts is cached on our local server, and when the lights go out via our smartphones, we have connectivity to one another. We have all of our friend network already cached in the local server, even though we don't have access to Facebook proper. In addition to that, we're using an off-the-shelf SIP-based voice communication tool, Asterisk, and SIP software on the phone to provide voice dialing. So with the simple IP bearer that we can create with a couple of access points and a few little Linux servers, we have restored basic data communication and basic voice communication. And the idea, as I said before, is that while the lights are on, this social networking engine in a box can communicate with a corresponding Facebook page, keep itself updated. During an emergency, when the lights go out, it continues to work. And then after an emergency, we have the data on that could presumably be turned into reports, uploaded to Facebook or what have you as appropriate. So I had a team build a prototype of this in the span of 3 weeks. It's amazing what you can do with off-the-shelf software and hardware today, technology today. And we actually demoed this at a disaster management exercise in Palo Alto in September of this year called Quakeville, where we actually let people try it out. We got their reactions, and in a rapid prototyping fashion, we turned that into a second iteration that we showcased at Carnegie Mellon University's Disaster Management Initiative workshop in November. Henning, I didn't see what you put up. You put up 3, 0. I'm out of time. All right. So I missed the others. I'm sorry. So we've built this twice already and demonstrated that in principle that it works, that it can be run on low-power devices, and then the interface can be made simple enough that it's really sort of training less. Things that we're thinking of in the future, just to sort of put in the back of your mind or as points of discussion, we're re-engineering the core software. Our hope is to make this open source and to let people actually use this widely as a disaster preparedness tool. Secondly, Wi-Fi, as we all know, has its range limitations. We're looking at building some software that will do some automated antenna optimization and things like that. In addition, we have made the following observation, as some others have. Most smartphones today are quad band, and in the United States, only 2 of those 4 bands are used. The other 2 are used in Europe and other places. And if we had an experimental license or an STA, we would have the possibility of lighting up those cell phones and using them in full cellular mode in the event of an emergency, something that we can discuss. Third is building mesh networks that network neighborhoods together. We have Professor Patrick Tagg at CMU Silicon Valley, who's already built a first version of network meshing, built a first version of mesh networks using laptops that we're integrating with a survivable social network. We're also adding some role-based functionality and some other things to support the city and sort of city to citizenry communication. And that is the Survivable Social Network. You can find more about us by searching for Survivable Social Network on your favorite search engine, or if you like URLs, there's a URL. All right? Thank you very much.
Thanks, Bob. I'm still trying to figure out why Henning's phone rings every 10 minutes. Yeah, I did.